So for the first one up here, we're solving for f. So we're just rearranging it just as though those other letters are numbers. Only we have to be careful that we can't combine certain things. So what's the first thing we have to get rid of there? Subtract c. So that's gone over here just like it would be with numbers. So we're left with mf over here. The difference is over here we can't combine p minus c. It's just going to stay p minus c. What's our next step? Divide by m. So we can get f by itself. So m's gone. We have f equals. And this is just going to stay just like it looks there. P minus c over m. Number 2 here is quite a bit more difficult unless you see one thing. We can just do this. Make it a proportion. I'm solving for a, which is here. The reason I did that is because a is on the bottom of a fraction, and trying to solve for a variable that's on the bottom of a fraction can be tricky. But if I do this and make it a proportion, I know that MA equals, if I cross multiply, what's C times 1? C divided by L. So MA equals C over L.
That's what I did, but why do you invert it like that?
What do you mean invert it?
Put the C over the top of L.
Because it's cross multiply and then divide. So you do, it's C divided by L, right?
Yeah.
So I put it in fraction form just so I can work with it.
So
No.
that was 2 under the L.
Yep.
Then it'd just be C2.
C over 2, yeah. Yep. Now I still have to get A by itself, so I gotta get rid of the M. It's multiplying A, so I'm gonna divide by it. So that cancels out. All I have left here is A. Now over here I am dividing by M. I can make that an M over 1. So what I'm going to look at that as being is when I divide fractions, I multiply by the reciprocal. So I'm going to multiply by 1 over M. So C times 1 is C. L times M is LM. So A equals C over LM. That one's kind of tricky.
What would you accept? MA equals C over L divided by M?
A equals C over L divided by M I would have accepted.
Oh yeah, A equals C over L divided by M.
Yeah, that I would take.
Would accept that.
Yeah. This last one has a little bit of ugliness in it. Nothing I can combine inside the parentheses, so I'm going to have to distribute the 2/3. 2/3 times 1 2/7 is 6/7. X. 2/3 times 3 3/4 is 2.5. Now I still have the minus 2 1/4 here, and 4 1/8. Any questions on that so far? So all I did is distribute the 2/3, multiply it through the parentheses. Now what would I have to do next? I can combine my numbers. I'm still working on just the left side. I'm not going to do anything with the 6/7 X, but 2.5 minus 2 1/4 is positive 1/4. So now I have to subtract the 1/4. So 6/7 X equals 4 1/8 minus 1/4 is 3 7/8. And I'm going to divide by 6/7. So X equals 3 7/8. I'm going to do 3 times 8 is 24. Plus 1 is 31/8. Dividing by 6/7 is going to be times 7/6. There is nothing there that cross cancels. So 31 times 7 is 217. 8 times 6 is 48. And that will reduce to 48 goes into 217 4 times with 25 48s left over, I believe. Anybody get that answer? That one was kind of ugly. Well, let's see how much else you remember from the last couple of classes. See if you remember how to do that one. I'll pause it for a second and give you guys a minute to try it. Where do you start this thing?
Make them denominators the same.
Well, first thing I do is make it 1/8 x plus 1/3 x. And then you're right. You do have to make this common denominators, right? So what's the common denominator going to be? 24. So 1/8 is 3/24. 1/3 is 8/24. Then what? 3 and 8 make 11/24 x. And then multiply by 24 over 11 or divide by 11 over 24, either one. Gives you that x equals 72. Any questions on that one? Let's try something like this. Give that one a shot. We'll look at it in a minute. So we start here with the parentheses. So the 5x isn't going to change. 6 times x would make 6x. That's positive 6x. 6 times -3, negative 18 minus 18. Equals 15, then what? 5 and 6 make 11x minus 18. Then we will add the 18, you're correct. So 11x equals 33, and then divide by 11. So x equals 3. As always, if you wanted to double check, you could go back and put the 3 in for x and see if you get the same value on both sides. It does work out for this one. Or we could try something like that. We'll work through this one together. You guys tell me what to do first. We'll subtract 3.5. So 3/4 x equals 4 1/8 minus 3.5 is 5/8. And then divide by 3/4. Yeah, you multiply by 4 over 3. Yep. This is multiplying by the reciprocals, all you're really doing. So you get 5 over 6. Or you might have something like this. You remember where to start with something like this? Yeah, the whole left side's been divided by 9, so we're going to get rid of that by multiplying by 9. So over here, that just cancels out the 9, and we're left with 2x plus 3. 3 times 9 is 27. Then what? Subtract 3. 2x equals 24. And then divide by 2. X equals 12. Any questions? Okay, so what we're going to look at today is something you guys are probably very familiar with, dealing with your positioning and stuff for CNC. And we're going to look at a coordinate system. Well, the way the coordinate system actually came about is from trying to show a relationship between two numbers. You guys are used to using it as a location, and that's one of the uses that it's developed into. But originally, let's say we just wanted to show that the number 3 was related to the number 6. Well, we've represented numbers on a number line before. We've represented 3 in actually a few different ways. One was that vector that started at 0 and went to 3. That's kind of our operational representation. If we're going to add or subtract, we like it in that form. But another representation is just to put a dot at 3. That represents the value of 3. To represent that 3 and 6 somehow work together, I can represent both of the numbers separately, but to represent the relationship doesn't work so well on a single number line. I mean, we're going to look at coordinates. So I suppose I could run an arrow from one to the other saying, hey, 3 is linked to 6 or whatever. But that would get very sloppy and very crowded. So what happened is a man by the name of Descartes took that concept of a number line and said we can take two number lines and set them perpendicular to each other. So one goes horizontal just like we're used to. The other one goes vertical. And it goes through the 0 of the first one and the 0 of that second one. The vertical one is also going to be in that same spot. So this will be 0, 1, 2, 3, 4, 5. And -1, -2, -3, -4, -5, and so on. So that point where the two number lines crossed, which represents 0 on both number lines, is called the origin. Because it's where both number lines originate from or begin. The horizontal one, you guys most often refer to it as the x-axis. It's also often in data analysis referred to as the independent axis. Because when you're representing data or information, that's the one that you can change. And this one up here, you guys usually refer to it as the y-axis. Again, in data and informational studies, that's usually referred to as the dependent axis. Because once you change the x value, the y value has to be determined from that. It depends upon that. So then coordinates, positions on here, are found by representing the x value and then the y value. For example, we had that point 3,6. Well, 3 would represent an x value, so 3 on the x-axis is right here. 6 is a y value, so on the y-axis, 6 is right there. The way we represent those two numbers together is we project them out. That point right there represents 3 on the x-axis and 6 on the y. That's the point 3,6. What's the value of that? What's the coordinate for that point right there? Careful. 4. So it's -7 here and 4 here. So it's -7, 4. How about this one? -4, -5. Good. And this one. That would be 7 and -2. Now they label these, you can see that the space here is split into 4 sections. Those are called quadrants. This is usually called the first quadrant. In fact, these are represented as quadrant 1 with the Roman numeral 1. Second quadrant with the Roman numeral 2. Third and fourth. Calling this one the first quadrant makes sense because both values being positive, that's where most of the stuff we do is going to happen. Going around counterclockwise is just a convention we use for trig and navigation and other things. So that's why we did that with these. Now some points that might be a little more difficult, like this one. What would be the coordinate of that point there? Perfect, -2, 0. If it's on one of the axes, one of the coordinates is going to be 0. You just have to figure out which one. It's like this point here. Which coordinate will be 0, the x or the y? The first one will be 0, right? That'll be 0, 7. It's on the y-axis. On the y-axis, x equals 0. On the x-axis, y equals 0. What do we use these equations for in math? Well, we've had systems or equations that look like this. 3x minus 2 is 7. How did we solve that? To find x. We add 2. 9 equals 3x, and we divide by 3, right? X equals 3. But a very closely related equation to that is this. 13 equals 3x minus 2. How do we solve that? Well, it's the exact same steps. You add 2. We divide by 3. 5 equals x. In fact, there's an infinite number of equations I can write like this. They would all be solved with the exact same steps. And the reason they'd all be solved with the exact same steps is this side of the equation is the same in all of them. All I've changed is this number here for each. These are what we call a family of equations, and we can represent them just like this. Instead of a number equals 3x minus 2, we just put in y equals 3x minus 2. Now we can solve all of them at once. Let me move down to the next page here. Rather than putting in values for y like we did up above, it's easier to put in values for x and figure out what y has to be. So I'm just going to pick some various values of x. Now the reason I'm doing this is I want to put these points on a graph. So I want to know different points across the graph. So I'm not going to pick just all positive values or all values that are right next to each other. I'm going to pick kind of a variety of points, positive and negative. So I'm going to do this. I'm going to do -3, -1, 0, 1, and 3. So that gives me kind of a nice spread. -3, -1, 0, 1, and 3. A little bit of a spread across the graph. So if x is -3, y is 3 times x, or 3 times -3, minus 2. That comes up to -11. I'm going to trust that you guys can do the order of operations to get that value once you put it in there. So that gives us the coordinate -3, -11. So -3, that's 5, 6, 7, 8, 9, 10, 11, way down here. If x is -1, 3 times -1 minus 2 is -5. So it gives us -1, -5 as a coordinate. So -1, -5, somewhere in there. X is 0, y is 3 times 0 minus 2, or -2. So that gives us the coordinate x is 0 and y is -2. So 0, -2 is right there. And at this point, those 3 points fall in a straight line. So we start to suspect that this is a line. But we'll keep going. When x is 3, y is 3 times 1 minus 2. 3 minus 2 is 1. So when x is 1, y is 1. So 1, 1 is right there. And when x is 3, y is 3 times 3 minus 2, which is 7. So x is 3, y is 7. So we get that line like that. So it does form a straight line on the graph. It goes like that. Now, not all of these are going to form straight lines like that. We could end up with something like this. So again, I'm going to pick values for x. I'm not going to write them all in because I might need a little more space to figure out y here. Not every point we pick to use is going to work. Sometimes we're going to get values for y that are so large or so small they don't fit on our graph. And sometimes it won't be enough. But we're just going to guess some points to start with and see where they lead us. So if x is -3, y is -3 squared plus 2 times -3 minus 8. -3 squared is 9. 2 times -3 is -6 minus 8. So that is a -5. So if x is -3, y is -5. There's a point right there. Well, that's not bad so far. Let's try x is -1. Y would be -1 squared plus 2 times -1 minus 8. -1 squared is 1. 2 times -1 is -2 minus 8. It's a -9. So we've got x is -1, y is -9. So -1, -9 is way down here. X is 0. Y will be 0 squared plus 2 times 0 minus 8. That gives us -8. So when x is 0, y is -8. So 0, -8. Well, I think we just ruled out the possibility of that being a straight line. If I try 1 for x, y is going to be 1 squared plus 2 times 1 minus 8. 1 squared is 1 plus 2 minus 8. That's a -5. So if x is 1, y is -5. So 1, -5 is right there. If we try 3 for x, y is going to be 3 squared plus 2 times 3 minus 6 or minus 8. 3 squared is 9. 2 times 3 is 6. Minus 8. So 15 minus 8 is 7. So if x is 3, y is 7. Right there. Now looking at this right now, I know what shape it is because I know what this equation is supposed to look like on the graph. But if I didn't know it ahead of time, I wouldn't have any clue really what's going on quite yet. I would say I need to know what's going on over here and maybe right in here. So by looking at the points I have, I'm going to decide, hey, maybe I need to know, if not -1, maybe -2, if x is -2, what it is. If x is +2, and maybe like -4 or -5. So let's do that. Let's do -2, -4, and +2 and see what we get. So I picked those first few points, put them on the graph. It wasn't necessarily enough, so I used what I had to figure out where do I need more information. So let's try -2. If x is -2, y is going to be -2 squared plus 2 times -2 minus 8. Well, -2 squared is 4. 2 times -2 is a -4. Minus 8 is -8. So that's -2, -8. -2, -8, that's going to be right here. That kind of mirrors that one. Let's try +2. X is a +2. Y is 2 squared plus 2 times 2 minus 8. That's 0. X is 2, y is 0. So it's right there, 2, 0. Let's try -4. If x is -4, y is -4 squared plus 2 times -4 minus 8. That also comes out to 0. So x is -4, y is 0 is right there. Now I'm comfortable going ahead to graph this. It looks like that. That's what we call a parabola. When you have x squared, that's usually the shape you come out to get. The moral of the story is you pick some points and make sure you pick a variety of points like I did. -3, -1, 0, 1, and 3. Pick a variety of points to get yourself a picture, kind of a general picture of the graph, and then zero in from there if you have to find the details to figure out what that graph looks like. Sometimes you're going to have to look at the equation and maybe try to pick values that work easily in that equation. So your homework for today is actually going to be a worksheet that I'm going to hand out here in a minute. And that worksheet is going to be on graphing. On this worksheet, for each of the graphs, I suggested some numbers in the tables. Like this x and y. I may have suggested some numbers here. That doesn't mean that those numbers are going to be adequate. It's just something to get you started. And for a few of them, I suggested numbers that work easily in the equation, so you're not getting really ugly decimals or fractions or something like that. So for tomorrow, there's going to be 10 graphs on that worksheet for you guys to do.